Thank you everyone for coming. I really appreciate it. I hope everyone's healthy and safe. It's nice to see so many of you here. Great to see lots of names I know. Great to see lots of names I don't know. So I hope this is a fun session. So today I want to talk about, excuse me, big data in linguistics, and I kind of want to focus in on both how big data is useful for doing really large-scale research, but also how it's useful, well, for still doing large-scale research, but really focusing in on rare items, so things that you couldn't have usually looked into. So I'm going to try to show sort of two different studies today. Sorry, I guess everyone's getting those beeps. I'm going to try to look at two different studies today to try to kind of make this point. Okay, so that's the basic argument I want to make, is that access to this really large amounts of data is really changing how linguistics is being practiced right now. I think we see a lot of sort of new research going on, some of it coming from other fields as well, but they're really taking advantage of these large data sets to try to kind of tackle new questions. I also think it's really important that as linguists we take advantage of this data too. I think to some extent, well, a fair bit of research coming from outside of linguistics, and I think it would be nice to see more and more of this research coming from linguistics. The real kind of big advantage, I think, to having so much data is just that language is really complex, right? If you take a look at grammatical and lexical forms, there's just such a diversity out there that really even just to observe these forms, you need to have access to massive amounts of data. So just to take kind of an obvious example, like in a multi-billion word corpus of English, we will find hundreds of thousands of unique word forms. And most of those are necessarily incredibly rare. This is just kind of this is just sort of a standard example here. Just a zip curve. So this is just this is from at least a portion of the corpus I'll be working with today. A few words and a sample of U.S. Twitter data. I'm just trying to show here how a few words are accounting for most of the tokens of this in this corpus. So a few word types account for most of the word tokens in the corpus. So the word I accounts for a really large amount of the words in Twitter, then the, then to, then you. But these are just the first 50 words. Obviously, there's a huge number of words in the English lexicon. And as we kind of zoom out on this zip curve, you can just see this really long tail of words. It's the top 500 words. You can see very quickly you're down to words that are occurring very rarely. Here now is the top 50,000 words. And what you can see here is just that a very small number of words, accounts for the vast majority of the tokens in this corpus. And these words at the tail end of this 50,000 words are not at all uncommon words. So in the last sort of 50 words, we have words like conditional, illustrations, converge. These are words that occur very rarely in this corpus, very large corpus, multi-billion word corpus. And these words, I think most people would say that these words are fairly common, and yet they only occur around once per 5 million words. That just lets you see how much data you need to really be able to study the lexicon as a system, and not just to study like the most common words in the lexicon, like say a few function words, or even a few common content words. But if you really want to study the lexicon as a system and start getting kind of large numbers of words, you really need big corpora, because most of these words are so uncommon that in any small corpus, they're not really going to occur at all, much less, many times that can let you find generalizations about how those words are behaving and how they interact with other words. Okay, so that's what I want to argue today, is that there's sort of two general advantages to having access to such large data sets compared to traditional corpora and other forms of data collection in linguistics. So I'm thinking of things as a sociolinguist, like surveys and interviews, but of any other type of data collection you want to try. If you want to get really large amounts of natural language data, we now have a source for that, and I think there are these two big advantages. And the one is to analyze variation at scale, or variation and change at scale, and the other one is to analyze very rare forms. And I think when you take those two together, they really let you start looking at language as a system to some extent, or at least at this scope for the first time. Until you have this kind of data, you can't really do this kind of research. And so I'm going to look here at two kind of case studies from my own work in lexical dialectology. I'm a corpus-based dialectologist, and I want to look first at the aggregated analysis of word frequency maps, and then to the spread of new words. The second study has been published a couple years ago in the Journal of English Linguistics. There's a citation for that at the end. The first study I have presented a couple times, although not all the information I'm presenting, some of it is new, but this hasn't been published. We're just sort of writing this up right now. Both of these studies are going to be based on a large data set. So this is about 9 billion words of American Twitter data from 2013 and 2014. It contains about 980 million tweets, about 9 billion words, like I said, and around 7 million unique users, or at least unique usernames. All these tweets are geolocated. All these tweets are geolocated, which means that I have the longitude and the latitude of the user at the time of their posting. And that then allows for a really detailed spatial analysis, which is what we'll be drawing on today. What I've then done is I've measured the frequencies, the relative frequencies of the top 100,000 word forms in the corpus. So I went through in the entire corpus, found the top 100,000 word types, and I've then measured their relative frequencies across the 3,076 counties in the corpus. And so these are American counties, and for each one, all the tweets that came from that county were sort of pooled together, and then I went through and measured the relative frequency of all of these words. Notably, to control variation in sample size, these all been normalized, right? So for every county, I know in total how many words are in that county from the tweets that come from that county, and then I've divided the frequency of each word by the total number of words in that county. This way, it's controlled so for the fact that the counties each have different numbers of total words in it. So obviously, Orange County or something like that, a big county with lots of people in it will have a lot more tweets, and so we want to normalize for that so we don't just get back sort of population maps. I should say all this data is available in various places online. I didn't put the link here, but if you go to my website or you send me a link, an email, I can send you the quantitative data. I can't share the raw tweets by Twitter terms and conditions. Okay, so let's jump in then to the first study. So first thing I want to look at is at these word frequency maps. This is something you couldn't really do in a traditional dialect survey. So there's obviously been lots of work in lexical dialectology. It usually involves giving some kind of survey to people, right? So you say, okay, well, what do you call a bun? Do you call it a bap or a cob or a bun or a roll? And people give you an answer. But these maps are different. So these are just maps of individual words, right? So this is just like how frequently the word the or the word I or whatever is used across the United States. And that's something you obviously can't get from a survey. I mean, you can ask somebody, do you use the word the? Do you use the word I? And they'll just say yes, but you certainly couldn't know like where people use it on average more or less frequently. Not compared to any other word, so not like a lexical alternation, like say garbage versus trash or bat versus bun. This is just overall, right? Like against the total number of words in any given text or in any given corpus. And so this is quite different from a traditional approach to lexical dialectology. But we can do this on a really large scale, and we can do this now for the first time because we have these big corpora that are all geolocated, and so we can go through and say, okay, so for every county, how often does the word I occur, relatively speaking, and then we can map the results. I think maybe the most remarkable part about all this is that of the top 10,000 words in this corpus, they all show non-random regional patterns. So they all do tend to be regionally distributed. There's not a single word in this corpus, at least in the top 10,000, that is just distributed at random. They all have non-random regional patterns on them, meaning that in some places, parts of the United States, in some sub-regions, in some areas of the United States, people use them more. In other regions, they use them less. And I think this is a really surprising result. It's only a result you can get with large corpora, large geolocated corpora, and it kind of to some extent challenges the scope of dialectology, I think, because dialectology has largely been restricted to these alternations. So let's take a look, I think, here at a few maps. So this is the map for I. I'm going to show you some sort of smoothed out maps in a second. These maps look a little bit messy, and probably the resolution's not great here. But you can see here that this isn't just sort of randomly distributed. You can see here in, say, Ohio, in Oklahoma, and parts of Texas, it's used relatively more. You have a darker color there, a higher relative frequency. In the South, you can see maybe, and in the North and the Northwest, up there in Montana, you can see it's used relatively less frequently. Of course, everyone uses the word I everywhere. It's not absent anywhere. It's an incredibly frequent word, the most frequent word in the corpus, but you still get this variation across the region in just how frequent it is. Here's another one. This is the second most common word, the. You can see this has even a clear regional pattern, being quite kind of uncommon in the Southeast, relatively speaking. Again, everyone uses this word, but it's used relatively uncommonly, and then more commonly in the rest of the United States. Here's the word to. Okay, so somewhat of a similar pattern to the, maybe not as strong. And then content words also show patterns. So here's cough. You can kind of see that it's not as common in the East as it is in the central United States. This isn't as strong as a pattern. This is obviously a much less frequent word, which is in part why it's shows a less strong pattern. There's less chance for a pattern here to develop, but nevertheless, there's still a pattern. And here is fever, maybe even less of a pattern. I'll kind of show you where the patterns are a bit better in a second. I realize these are a bit hard to interpret. And then finally, just one here, just to kind of, as sort of a sanity check, here's the word Washington. And you can see here both that it highlights up around Washington State in the very top left corner of the map, but also around Washington, D.C., over on the central East Coast there. Okay, so those are a bunch of word frequency maps, and basically we have word frequency maps like that for 10,000, 100,000 words, depending on what data set we're going to work with. And so, like I said, all those maps show regional patterns. They're a little bit hard to appreciate those regional patterns because, of course, these word maps are really sensitive to a lot of different factors, and they're not just purely kind of regional. They show up all sorts of different types of phenomena there. But it is kind of useful then to try to pull out the regional pattern from each one. It's useful both just to visualize it so we can appreciate it, but it's also useful to pull those maps out so that we can kind of focus in and analyze just the regional patterns and kind of leave the non-regional information behind. So to do this, I do something called hotspot testing. I'm not going to get any kind of statistical details here at all, but basically what it does is it goes through and tries to extract and then map the sort of broad underlying regional patterns in each word map. So it's kind of what it's trying to do is sort of isolate the signal, the regional signal in that map, and then present it to us. It's very similar to kind of doing an isogloss analysis, which is common in dialectology. It's just that it's been automated, which to some extent limits, my own bias here. So here, for example, is the map for I. And you can see now it's quite a bit clear. You get these hot spots in, like I said, Oklahoma and Texas, Ohio there. You get really cold spots up there in the Northwest. So this just shows where people are more likely to use the word I. Here's the map for the. And if you recall, it had a very clear pattern, and here it is again. You can see it's used relatively infrequently in the southeast of the United States, more frequently in the north and in the west. Here's the map for 2, and you can see it's not as strong, but you get kind of an east-west split here to some extent. And then as for the more content words, here's cough, so more common in the central United States. You can see there really hot spotting kind of in the Great Plains. Here is fever. Okay, so kind of maybe a weaker pattern overall and a different pattern than cough. And then lastly, here is Washington. And you can see it works quite well. You can see there's Washington State highlighted in the upper corner. You can see Washington, D.C. highlighted. And you can see lots of other little hotspots around. Most of those, I believe, at least the ones I spot checked, just correspond to cities and counties in Washington. So in the middle of the map, you have Iowa there, and there's Washington and Washington County, and that's what's happening there in the very middle of the map, that kind of secondary hotspot. Okay, so that's a lot of maps, and it's obviously quite hard to make sense of those. I mean, like, what do those maps even mean, right? Like, are they even meaningful? I mean, they show regional patterns, and and they all show regional patterns, but what can we get from that? So one thing we can do here is that since we have this large number of lexical maps, about 10,000 maps here, we can start to try to see if there's any kind of common regional patterns in that data. And then we can try to see if we can interpret or see any similarities between the words that show common regional patterns. So to do this, I just did a dimension reduction. Again, I won't go into the details, but there's a little bit of detail there. And I pulled out the 5 most common patterns from that complete set of 10,000 hotspot maps. The way I like to think about this is if you took those 10,000 maps and you took a look at one, and you said, okay, well, this one here pulls out the southeast. I'm going to put this in a pile. This next one pulls out the west, or contrasts the west and the east. So I'm going to put this in a pile. And you keep doing that, right? So you do all 10,000 maps, and you start sort of putting them into piles of ones that look similar to each other. And at the end of that, you have a bunch of stacks of piles. And you take a look at the biggest pile and see what is the kind of common pattern, average out all those maps. That's basically all that this is doing. And so what it's saying is out of these 10,000 maps, these 5 patterns in the order presented are the most common patterns in those maps. So here's the first map, and it contrasts basically the southeast with the rest of the United States. It's a very strong border. It's a border, I don't actually have the map here. I'll show it, I think, at the end of the presentation, but it's a map that corresponds very closely to what you might think of as the divide between the North and the South in the United States, say back from kind of Civil War times even. It also maps very closely onto the population of African Americans in the United States. So there's tends to be higher percentage of African Americans in counties in blue there as well. That is the first big pattern we find. I'm going to come back and kind of talk a bit more about how to interpret it in a second, but I'll show you the next pattern. So this is the next most common pattern, and this really contrasts the coasts against the central United States. And to some extent, this maps onto things like urban versus rural. It also maps onto sort of Democrat versus Republican. So the more kind of urban, liberal area in blue, the more conservative rural area in yellow. Again, what we find here, right, is that there's a whole bunch of words, and I'll show you some in a second, that all show this kind of pattern. And the analysis lets us say, okay, well, here's a bunch of words that show a pattern that look like this. This is sort of like an averaged out version of a bunch of maps that show this pattern. The third most common pattern contrasts the east with the west, especially the northeast with the west. Okay, the kind of border you see there in the middle of the map corresponds basically to where the Great Plains are, to what splits the east and the west. The Rocky Mountains are right on the western edge of that area. Here's the fourth most common pattern. So this is pulling out kind of the southwest against the rest of the United States. This maps fairly closely onto Hispanic population. So there's more people from a Hispanic background in the blue area of the United States. And then here's the fifth area we find. This one's maybe the most kind of unexpected, but broadly speaking, what you see there in blue are kind of more mountainous areas. So you see the Rocky Mountains on the west side. In the center of the map, you can see where the Ozarks are in Missouri and Arkansas, and then in the at least in much of the eastern part of the map, you can see where the Appalachian Mountains are, or at least where the sort of the core is. Okay, so those are these 5 dimensions we found. Like I said, these are basically just the common regional patterns that are in that set of 10,000 maps. But what we can also do is try to say, well, what words are most strongly associated with those regions? And by looking both at the maps and the words are most strongly associated with each of those general aggregated maps, we can start to try to figure out what are some cultural differences between people posting on Twitter in 2013 and 2014, both how they tweet, like the language they use, and why they tweet, like what topics they're talking about. I'm just going to go through a couple here for the sake of time, but these are like the top 8 words that are in the southeast and the north. So the maps for those 8 words, there's hundreds, but the maps for those 8 words are the ones that most show this kind of pattern. So ain't, that's ain't without the apostrophe T because that was split off as a separate word. About, gotta, somebody, everybody, gone, y'all, and why spelt that way. So those are words that are very characteristic of that southeastern region. Alternatively, Words that are very characteristic of the more northern region in yellow there are words like are, guys, excited, of, such, actually, and into. I think if you know a bit about American dialectology, you can already sort of spot some differences. So, for example, y'all and guys are getting picked up there, right? These are, second person plural pronouns, right? You can also see lots of sort of things that are related to, or at least you can start to see things that are related to African American English in the South there as well, like gone, about, stuff like that. But you can also see some topical patterns on these too, and I'll come back to that in 1 second. And then here are some words then that distinguish this sort of area in blue on both coasts, although the words are on the left side of your screen, and the area in yellow. And so you get words like Dunkin' from Dunkin' Donuts, dinner, yo spelt that way, the word deadass, ice, fucking, Panera are all more common in these more urban areas. In these more rural areas, you get words like quit, glad, crap, sure, dang, contracted, have, and ready. Now, again, these are even still kind of hard to interpret, right? But I think you can start to see some of the differences here, both structurally, linguistically, and topically in terms of content. We've actually done this in some more detail than this. So we've gone through and really looked at the top few hundred words from each of these patterns. And we've made a distinction. So we put out the content words on one side and looked at those, and then the more the function words on the other side and looked at those. And we tried to kind of see what are some differences we can see. And these are just the first 3 dimensions. But we see these, for example. So we see in the north, people are more talking about evaluation. You get a lot more quantifiers, a lot more hedges, a lot more adverbs and stuff. In the south, you get more social engagement. So you get a lot more pronouns in general, but you also get a lot more kind of words about engagement. So communication verbs, stuff like that. And so we see a topical difference there. In the East, we see a lot more discussion about things related to family life. In the West, we see a lot more things related to outdoors and to travel and to work to some extent. On the coasts, we get more urban life words. On the inland areas, we get more rural life words. These are maybe all kind of obvious to some extent, or maybe the second 2 are obvious. I'm not sure the distinction between north and the south topically is obvious. But we do get these distinctions, and they're sort of borne out in a data-driven way from the ground up. We're not presuming any of these. We look at the data and we interpret them. Interestingly, we also get these stylistic differences, which I think aren't totally unrelated, right? So we get more of an informational style. So lots of nouns, lots of noun modifiers, lots of prepositions, stuff like that in the north. And in the south, we get more interactional forms. So lots of pronouns, lots of discourse markers, lots of hedges and amplifiers. In the East, we get more personal forms. In the West, we get more impersonal forms. And there's clearly a real difference between a more non-standard, sort of slangy style on the coasts and a more standard style inland. And so these are some of the differences that we can pick up here by doing this really large-scale quantitative analysis of these individual word maps. And I think these aren't things you could really get to via alternations. You might say in a sort of a dialectology study, who even cares about topic? And you might be right, but these stylistic ones I think are of interest to linguists. But I also think that these topical patterns, when you look at the relationship between the topical patterns and the stylistic patterns, you start seeing some parallels there, that there's an argument that the topical patterns are pretty interesting to linguists as well. Maybe not directly as what we study, but maybe to help explain some of the broader regional linguistic structural patterns we see, that these 2 things aren't disconnected. Finally, I want to show you that we can also use this to kind of try to pull out cultural regions. And so the idea here is that we take all 5 of those sort of aggregated maps and we can put them together and see if we can kind of cluster out different regions of the United States. This is the main kind of goal of this research. I'm not highlighting it here today, but of the project we're working on, we're really trying to say, can we find cultural regions from the ground up? Basically, instead of presupposing what matters, can we just find what people tend to be talking about, and then can we use that information to say, okay, well, if people who are from the similar cultural regions are talking about similar things, can we then try to figure out regions based on topics people tend to discuss? So we just do this with a cluster analysis, but here are the regions. Okay, so you get 5 regions here, and I think they're all quite interpretable to a North American or to an American who kind of knows. They're very similar, say, to the census regions. They're very similar to I don't know, the regions you get for, say, like, I don't know, sports leagues or something like that. So in purple, you have the Northeast, which captures all the big northeastern cities, as you can see, including from Washington, D.C. up to Boston, basically. In orange, you have the Midwest. You have a clear border there between the Midwest and the South in green and the Northeast in purple, which is basically the Appalachian Mountains. You have another clear border on the other side, which is basically the Rocky Mountains, which separates the West in pink from the rest of the United States. And then you get this southern region, which looks, broadly speaking, like the South as generally defined. You also pick up that area in blue, and that is more or less the area of sort of really high African American concentration in the United States. And so what we're finding here is these sort of 5 basic cultural regions, which correspond, broadly speaking, to what people believe. But here we found them from the ground up, based on what people are talking about on Twitter. There's quite a bit of work in trying to infer American cultural regions, but generally just based on people's opinion about what factors matter. So maybe people look at economics or at voting or even at dialect patterns. Here what we're doing is saying, let's just move from the ground up and see what we can find. So I wanted to show this too. This is kind of preliminary research, and I kind of got to go through and double check all this and make sure everything's right. But this is something we've been doing just recently, just with COVID. So what I kind of want to do here was, look, we know that, or I've argued so far that basically these word maps can tell us a lot about cultural patterns, right? That they can help us find cultural patterns in American society here. So what we can also do then is take societal issues of importance that we have maps for and run the maps back against all of these word maps and say, okay, let's see what word maps align to the cultural map we're interested in. We did this previously with Trump's the voting by county on the 2016 election. So we took the percentage of Trump vote by county and correlated it back against these 10,000 words. There's an article in Quartz. If you look up Quartz and Trumpiness, I think it would be you'd find it. And there we found that the map that best predicted the Trump vote was crap, and the map that best predicted the Clinton vote was fuck. Those two maps look almost opposite to each other. They look a lot like that distinction, that map that distinguishes between the rural and urban United States. In fact, if you go back and look, you'll see that one of the rural words was crap and one of the urban words was fucking. But those are the two words that best predict the vote. So the Trump vote's best predicted by crap, and the Clinton vote was best predicted by fuck. But we now tried this with the COVID data. So this is basically just the number of cases per million words back in March 18th, just when I downloaded the data. And then what I did was I took that map and correlated against the top 10,000 maps in the Twitter corpus. And the goal here is basically to see it's very exploratory. There's obviously a lot of confounding factors here we haven't looked at, of course. But it's just to try to gain some insight about what cultural factors might have encouraged the early spread of disease in the United States. Here's the COVID map from back in March. So this is just the redder the dot, the more people were infected there per million. So it's been normalized for population. I also hotspotted this map. It looks something like this. So you can see the hotspots. These shouldn't be so surprising. Maybe these are a little bit exaggerated, but you get the Washington State one, you get the New York City one, you get the Louisiana one, you get the Colorado. Those are all well-known hotspots. Okay, so the idea here is to take this map now and to correlate that against each of these 10,000 maps that I've been showing you. These are the words that are the best predictors. Again, I kind of want to double check all this and kind of maybe improve the statistics a bit, but broadly speaking, I think these are all going to be in the top no matter what. You get some interesting words in here. I want to kind of just focus in on these ones that are related to like eating out. So you can see brunch, cafe, cocktail, chef, barista, cocktails, etc. are all there. And you can see that all of these show very similar patterns. So here's the COVID map again. Here now is chef. Here now is brunch. Here's cafe. And here's cocktail. You see to some extent all of these maps really align closely. Of course, this is from 5 years before COVID or 6 years before COVID, but I wouldn't imagine the kind of cultural variation on the ground has changed so much over that time. And so what we're seeing here is that, a lot of these words that are related to eating out sort of align with the COVID result, the COVID spread. We can see that also that words that are related to working, so desk and executive, panel, various things like that are there. And we can also see, if we go farther down the list, there's quite a few words that are related to commuting, so traffic, train, airport, flight, destination are also all on that list. Anyway, what this is worth, I'm not sure. I just thought I'd show it because it's sort of something we're currently working on, and it's sort of based on this same general approach. And the idea here is try to kind of find these cultural correlates of things that are happening. If words show cultural patterns, then we can use them to try to figure out sort of cultural explanations, potentially, at least make hypotheses about cultural explanations for things that are happening in the real world. So to sum up this first half of the talk, these extremely large corpora are really useful. They allow for the truly large-scale analysis to be conducted for the first time in linguistic domains that are characterized by large numbers of forms. And I think that includes both, lexis and grammar at least. We've done more with phonetics and phonology and language variation and change at least. I think that's because we can get that data a lot easier, and there's not that many vowels in the English language, for example. So you can get a reasonable measurements of those off of pretty small amounts of data, but not when you're doing lexis, not when you're doing grammar. And I think this opens up not just kind of descriptive research, but also for more theoretical and applied research. I'll try to illustrate some applied there at the very end. Okay, so the second thing I want to show is the spread of new words. So this is published research that you can get your hands on. There's a link at the end. This is work with Andrea Nini at Manchester and Diancheng Guo at South Carolina. And the idea here was to really try to understand about how new words are spreading and using Twitter to do this. To me, this is a fundamental part of linguistics, certainly a fundamental part of sociolinguistics, and that is to understand language change and to understand how innovation arises and how innovations spread. And this is something that's very difficult to do, right? I mean, we have lots of research on individual linguistic forms, but we really don't know how language changes in general, and even those individual forms have all been essentially kind of cherry-picked, right? There are ones that people happen to notice, let's say, and that's great, but it doesn't really give us a complete picture, and it doesn't give us a very unbiased picture. So the idea here is to try to understand the spread of new words on Twitter. So just on Twitter, which is obviously a very restricted domain, but still it's the domain that this moment that we can really look at in detail. So it's based on the same corpus, and trying to figure out if we can find new words right when they're taking off back in 2013, 2014, and then seeing if we can map where they're coming from and how they spread. So the basic approach we use, which is fairly simple, I think, is that we go through all the words in the corpus. We have hundreds of thousands of words, 100,000 words, let's say, and we try to find words that match two criteria. One, we try to find words that are very infrequent at the end of 2013, which is when our corpus starts. So we try to find words that at the beginning of our corpus, because every tweet in this corpus isn't just geolocated, it's also time-stamped. We try to find words that at the beginning of the corpus hardly occur at all. I mean, ideally that don't occur at all in 2013. And then we try to find words that have really taken off over the course of 2014. So we're looking for words that show real rapid rises in their usages. And if we basically cross-reference those two lists, we can find words that were very infrequent at the beginning of at the end of 2013, and then that took off over the course of 2014. And that's what we're calling emerging words, with a little bit extra filtering here too. We're also going to focus in on words that aren't in a standard dictionary. So just to show you first what the data looks like. So this is basically what we have. So in addition for a map for all these 100,000 words, we also have a time series for all these 100,000 words. Basically, this is just showing how frequent the word is used over time. And here's the time series for the word moon. you can see that on every full moon you get a peak in usage, right? So it spikes up. These are like these sort of Google Trend graphs you might have seen. You can also see this one huge peak in the middle, and that's because that was a supermoon, so it got lots and lots of discussion. Okay, so that just sort of shows the kind of data we're working with. Obviously, this isn't the kind of word we're interested in. It is actually fairly infrequent, but it's not super infrequent, and it doesn't show like a clear rise. You have other words, like here's the word I. So we saw that I is the most frequent word, but it's also, at least over the course of 2014, became less common on Twitter. And you can see a gradual fall here. It's a little bit more complicated than that, but you can certainly see a gradual fall here. What we can also see here is a pretty clear difference with how much the word is used on the weekends and the weekdays, with it being used less often on the weekends. That's that kind of oscillation you see. Here's now the time series for two different words. Sorry, skip there. So here is the word for the map for on fleek, which is a word that took off over this time period. You can see it starts off at 0, and then all of a sudden it just shoots up in this sort of exponential growth in sort of mid-2014. Here's another one. On fleek means good, basically. Here's another one. This is the time series for Bayless. Bayless means to be single. It's not used very much anymore. It's since fallen off. But back in 2014, it shot up briefly and did fairly well throughout that year. It's a formation off of the word bay, which itself is a relatively new word, which means your sort of partner. So bayless means to be without a partner. So these are the types of words we're looking for, right? We're looking for words that start off super infrequent at the end of 2013. So like this one, you see it's very infrequent at the beginning of that time period, and then that show this really dramatic increase in usage over the course of the year. And those to us are these emerging words. Okay, so that's what we do. We cross-reference those two. And then what we can do if we want is we can visualize this. So we can now visualize all the words in the lexicon based on these two measures. And then we can, based on this, kind of isolate the words that we want. These are words that are very uncommon that are emerging over time. So here's a graph. I don't imagine this will show up great in the resolution, but this is a graph showing all the top 50,000 words in the corpus, and it's plotting growth rate by starting frequency. The frequency is logged. That's on the vertical axis. Okay, so the higher up you are in this graph, the more frequent the word is. You won't be able to see it, but like if you look in the very top left corner, you'll see a little dot up there, right kind of below the word top. That's the word I. Okay, that's the most frequent word in the corpus, right? And then on the horizontal axis, on the x-axis, you see is the word increasing or decreasing its frequency. Okay. Excuse me. The farther it is to the right of the graph, the more it's increasing in frequency. The farther it is to the left of the graph, the more it's decreasing in frequency. And that little dot up there, I, under the word top, well, that's very high because it's very frequent, but it's also very far on the left side of the graph because, as you saw a few slides ago, it really was decreasing over the course of 2014. The words we're interested in, though, are the words that are in the very bottom right-hand corner of this graph. These are words that were very infrequent at the start of the corpus, at the end of 2013, but that really shot off over the course of 2014. And we can zoom in on those. Okay, so I'm just kind of zooming in here to this bottom right-hand corner. And you can see what I'm saying here. We can now look at this whole kind of lexicon as a system, right? There's obviously lots of ways of doing this, but this is one way. We have this whole lexicon now, all these words, and we can look at it as a system, and we can zoom in on parts of the system that we're interested in understanding. And I think these words are especially interesting. Well, those are obviously lots of others. So here we are now getting on the very edge of this cloud, down in that bottom corner. And as we zoom in, we can start to see these words. So these are the words in the very bottom corner of this graph, the very bottom right-hand corner. So these are words that start off very infrequent at the end of 2013, but that became very frequent or became dramatically more frequent over the course of 2014. And you'll see a lot of the words that we're going to talk about here in a second. You'll see some words we won't talk about. What we did do here was remove words that are already in a dictionary. You see the word oppressed, you see the word Palestinian, for example. Those are words that were really taken off. You'll see feminist if you look in there. Those are words that were really taken off. E-commerce, that were really taken off in 2014. Well, maybe e-commerce would have made the cut, but but Palestinian and oppressed wouldn't have, right? These are well-known words. But they just happen to be very uncommon on Twitter, but they became popular over that time period for social reasons. But because they're in dictionaries, we remove them. We also removed all the proper nouns. So there's a lot of like, in particular, app names here. So group chat, or maybe that's not one, but well, anyway, there are quite a few in there. Snapchat might be in there or something, right? And there's also some people's names in there that we remove. So these happen to be people who happen to become popular over this time period. Okay. But after we remove these, and we also remove all the lemmas, so we only have the most common lemma for each word. So we don't have kind of inflectional variants here. These are the 54 words, I believe, that we found that were emerging on American Twitter in 2014. I'll just give you a second to take a look at those. I'm not going to go through and define them all. You'll know some of them, so you'll see Bayless there. Balayage is a hairstyle. Boolin, it means coolin. Brazy means crazy. Candids are a type of picture. Selfie is an alternative spelling. You will see spelling variation here counted. You'll see acronyms counted. You get words like cosplay, which you might know. Famo means family and friends. Faved is an internet term. Fleek we saw. Fuckboys was a derogatory term that really took off over that period. Gains with a Z. It doesn't just mean gains with a Z, S. It means weight gains from eating well and working out. Senpei is like an older authority figure or something like that. Waifu is from a similar kind of topical area. Tuka means marijuana. Trap house is a place people sell drugs, also a musical genre. Xans is short for Xanax. TFW is that feel when. You'll probably recognize some of these. Some of these have already come and gone. Some of them have become quite popular. We have another paper where we show which ones become more popular over time, like they've stuck around. Lit has done very well. Litty has done well. Okay, but what we can also do now is try to track where these words are coming from and how they're spreading. So that's kind of the main goal of this as a dialectologist, is to try to use this data now to try to see if we can see where these words are coming from and how they are spreading out across the United States. Of course, this is just on Twitter. The extent to which this generalizes is unclear and almost certainly not wholly. It's also clear that most of these words do not, if not all of them, do not originate or spread primarily on Twitter, which maybe should give us a bit more confidence that this maybe does generalize, but that's not really the point. The point's more to see how these things are spreading on Twitter and to understand that. As we get more and more data online, we'll be able to do this on a larger scale with lots of different registers and see how things vary across different communicative contexts. But for now, I think this is probably the only data that we can really do this with. Okay, so we can do this in a lot of different ways, but probably the simplest way is just to map the frequency of these words over time, okay? So here it is in June 2014. I'm looking at the word fleek. You can see in June 2014, it has a very limited distribution on Twitter. You can also see it's not all concentrated in one part of the United States, okay, which I think shows you that this isn't obviously this didn't start on Twitter. It certainly didn't start on geolocated Twitter, but you still get some kind of trace here of where it was common early on. So here it is in 2014, June. Sorry, these should go a bit faster, but we'll do it slowly because of the technology here. So here it is in July. You can see it spreading out. Here it is in August. You can see it really took off over the course of July and August. Here it is in September. Here it is in October, and by that point, it's really taken over most of the United States, although it's concentrated in the South and the East. We can also take all those maps and kind of reduce them down to a single map, and that's really useful. So this is somewhat similar to the hotspot maps we were looking at before. It's a little bit more difficult, or a little bit more complicated. If you want to get the details, you can read the paper. But this is the map that basically shows where this form was most concentrated early on. And you can see it really hotspots there in kind of the South, but really kind of the eastern half of the South. We actually know the person who came up with it. They were from South Carolina. They were living in Denver as well, though, which doesn't hotspot there. Here's a few others. So here's the map for Bayless, okay? So we can see here that Bayless is also a southern form. I mean, the way to read these to some extent is that the darker the red is really where it occurs earliest, and then where it's lighter reds where it kind of spread out. And so not only can you kind of see where these are coming from to some extent, but you can also see how they've been spreading to some extent. I mean, very broadly, right? Here's Lort. So this is like usually used like an exclamative, like the word Lord, but used to express an exclamation. You can see that's also in the South, but more on the Gulf Coast there in Louisiana especially. Okay, and so what we've now done is we do the same thing that we just showed with those word maps. We try to find common patterns. So very similar. We use dimension reduction. We take, this is just, instead of 10,000 maps, it's these 54 lexical emergence maps, and we find 5 common regional patterns. Okay, and we interpret each as being basically a hub of lexical innovation. That's the real core area, and then we also see where it diffuses on Twitter. So where the word had spread earliest and most consistently. So here's the first pattern. It involves all of these words. So these words are all associated with this pattern. You'll see some topical clusters in here. You get words that are associated with computer language, like faved. You get words that are associated with kind of anime culture, like waifu and senpei. You get lots of different spelling variants and acronyms as well. And this is where these forms are used most often. This is the least sort of regionally kind of cohesive area. It seems to be basically an urban pattern. You get New York City, you get Los Angeles, you get San Francisco, you get kind of the urban kind of coastal regions here. Here's a map of population density for comparison. You see it's very similar. So that seems to be kind of like a general urban American pattern. Maybe as we interpret it, kind of more focused on the West Coast, but certainly spreads out more widely. The second pattern is this one here. So words like Bayless, Boolin, Brazy, Fallback, Tuca, Trap House, Fleek. You might recognize these as being, or at least seeming to be, more associated with African American English. That's certainly what the map would suggest. So this is the area where these are used in the South. Okay, you can see the real hot spot there. The core area is on Atlanta. But you can also see, I think I said I'd present this earlier, but you can see how well this correlates with just the map of where African American population density is highest in the Southeast there. The next one has these words, so these various forms of lit plus balayage, the hairstyle, so a much more kind of reduced set of words. But this one here is very strongly associated with the New York City area. Okay, so these are words that appear, at least on Twitter, to have really started their rise in New York City and have spread out to some extent from there, although not nearly as widely spread as those first or second set of words. The fourth set are these words here. Again, kind of a mixed bag here. And these words are more common on the East Coast, but especially in the sort of mid-Atlantic area around Washington, D.C., Baltimore, Philadelphia, down to the Carolinas, with this sort of secondary hotspot in Chicago. And then finally, we have this one more that has these very few words in it. Lort, get me fucked up, I don't get tired, and selfie. And these are all associated with Louisiana on the Gulf Coast. In fact, we know that I don't get tired was coined by a rapper whose name I forget, but who is actually from this area, from Baton Rouge, Louisiana. And when we put them all together, we get this map here. So this really shows you, it's essentially another kind of cultural map of America, right? And this one here shows you where new words tend to be coming from and how they tend to spread. And it shows quite clearly, I think, these sort of 5 sort of areas of concentration. And they are basically located on New York City, on the Washington, D.C. area, on the Atlanta area, on New Orleans and Louisiana, and on the West Coast, especially in California, the Bay Area, and Los Angeles. I don't doubt these will change over time. I don't doubt these would be different if you looked in other registers. But on Twitter, at least, these are where lots of new words tend to be coming from, or at least where they tend to be being projected outwards from, and this is where they tend to then spread. So to sum up that, basically we find that new words tend to emerge from 5 main regional hubs on American Twitter. Each of these hubs are associated with a core urban area, as I just described. But I think it's important to note that these are not just the largest cities in the US. Rather, what they appear to be are really culturally significant cities. So of course, New York City is a really large city, right? But New Orleans isn't an especially large city. It's maybe the 50th in the United States, 50th most populated city in the United States. Why is it so important? Well, I guess it's, very culturally important, right? I mean, we all know, we've all heard of New Orleans and know it's important culturally. Same thing with Atlanta, right? I mean, Atlanta is a big city, but it's about the 10th biggest city in the United States. It's not the fifth biggest city, and it is incredibly culturally important as a real hub of African American culture. So I think that's what we can see, that new words on Twitter at least tend to be coming from urban areas, but from really culturally important urban areas. Well, I think what we also see maybe most clearly is just the influence and the importance of African American English and African American culture on lexical innovation, at least on Twitter, but I would imagine that's a more general result. We also can see that lexical spread tends to be constrained not only by geography and by population density. That's kind of what we expect, right? There's what's called the wave model and the gravity model predict this, but also by cultural borders. So we can see, for example, that in Atlanta, although it is like the real kind of core of one of these regions, we can see a real hard border right on the northern edge of Atlanta. And there's a real hard cultural border there between more white people on one end and more black people in the south. So we can see a really clear effect of cultural patterns. Not something other people have recently found too. There's a nice Jacob Eisenstein paper about this in PLOS ONE. Anyway, there's the link to the paper if you want to give it a read. It's open access. Okay, so finally, just to conclude, the sort of general argument I want to make, and I hope I've done an okay job of sort of supporting it, is that very large corpora allow for the observation of really large numbers of linguistic forms, not individually necessarily. I mean, well, you could, but also together as in the aggregate and as a group. And this also includes extremely uncommon forms. I mean, all of those new word forms are extremely uncommon, right? Like, you really need a huge amount of data before you can start seeing those types of words from the ground up as they rise up. What I think this does is it really opens up the possibility of analyzing language as a system, how large numbers of forms interact in natural language, in reality, right? Especially in the lexicon, which is a really long neglected area of research in variation studies. We might ask why that's the case, right? Like, why is it that most variationist research focuses on phonetics and phonology to a lesser extent grammar? And I think that's because, I mean, I really think to a large extent it's because it's what's been doable. Like, you can go out and do interviews and get lots of data on vowels and really have a rich study. I mean, if you look at sort of sociolinguistics in the last 20 years, there's been a lot of research, really interesting and powerful research on vowel systems. And that's really looking at vowels as a system, right? I mean, as opposed to kind of older research where one might just look at an individual vowel or an individual grammatical form. And when they look at the vowels as a whole system, you start seeing these really interesting complex interactions. You get chain shifts and stuff that aren't really appreciable otherwise. It's really hard to do that with the lexicon though, because there's not just, it's not just 40 vowels, right? We have hundreds of thousands of words. It can also really help us understand the interaction, I think, between language and culture. I think that's something that we can really start to get a hands on here. It takes a lot of data to do that, lots of cultural data and lots of linguistic data. And in my mind, that's really central to understanding language variation and change. And I think that's probably something we'll see increasingly over the next few decades as people start to really be able to kind of work cultural stuff, cultural information into these linguistic analyses. So for example, the research I've shown today has really shown how language and culture shape each other. And that's in a level of detail that I don't think we could have done even like 5-10 years ago. And then lastly, I just want to say that, this has all been Twitter based, and there are certainly some limitations there. I mean, I think it's really important to understand that, anyone who's looking at any kind of natural language is looking at a specific register. So even if you're looking at casual conversation, which almost nobody is really in sociolinguistics, let's say, but if you're looking at casual conversation, that's a register, and there's a difference between different types of casual conversation. There's a difference between face-to-face and telephone conversation. There's a difference between conversation on different topics. And so, yeah, we're just looking at Twitter here because that's what's available, but it is at least grounded in a real register. And increasingly, we'll see more and more registers online, including spoken language, where we can get this in large amounts. That will really let us even better understand language variation and change and how it interacts with culture. We can really see how language varies across registers, which are, to some extent, essentially how we define a culture, right? By the communicative context in which we have. I think it's going to open up some really interesting and important research questions over the next few years. And this data is more and more accessible. The methods are more and more accessible. So I hope a lot of people take advantage of that. I especially hope that linguists take advantage of that, and we don't just leave this all for computer scientists. Uh, thank you very much.
Okay, thank you, Jack. I think it's time for question. And so as I said earlier, and just type your question and raise your hand, and I'll call your name, and Jack will be able to read out your question and answer your.
I'm happy to take questions.
Yeah.
Assume people. I assume that was all audible.
I think so. I've been able to hear that, and I'm also